So the DARPA repair project that we're involved at here at Brown is really focused on understanding how it is that the complexity of the brain supports our ability to both process sensory events and to move in the world. And then to take that kind of knowledge and say, well, if things break, if there is a disorder, if there's an injury that actually leads to some kind of dysfunction in the brain, do we understand enough so as to substitute the missing part or the broken part with some of the kinds of control technologies that we're trying to develop and replace that function?
What the project we are undertaking aims to do is to engage a conversation with the brain in ways that simply has not been possible before. To establish this two-way communication with the brain, we've created a first version of a new generation of these types of dual function devices. Light in, electrical signals out, which we call optrode arrays, that can be surgically implanted into selected areas of brain that have this light-enhanced sensitization, and at the same time enable these devices that deliver the light to be able to listen.
What has really been fascinating to me is taking some of the work that was ongoing at Brown and jump over, if you will, electronically with computers, a damaged nervous system so that you can restore function in a hand or a leg, and beginning to broaden that to a much more complicated situation with traumatic brain injury. That it shows the value of basic research.
With the optogenetic technique, now we're able to not only record but also suppress the activity of the brain on a trial-by-trial basis. If you want to understand what a part of the brain does, take that part of the brain offline, then you can see what function is missing. And that kind of tool is even more powerful if you can do it transiently. The capability to do that is really unprecedented in neuroscience.
With this new direction that we're taking, the hope is that we can show with some certitude that we can manipulate activity at the level of a small population of neurons and have a demonstrable effect on behavior. We can make animals report as if they are recognizing an object, or we can show that in the course of looking around in a complex environment that if we are to stimulate in a particular area, we can bias where the animal might look.
It's the power of science to ameliorate some of the effects of these tremendous injuries we're seeing. And without the federal support, that research wouldn't be done. Without the intellectual capital at Brown, it couldn't be done.
And the dream here really, at the level of helping people who might be injured, is to create a device-based technology that could one day substitute for any number of inputs to the brain, creating a repair mechanism that enables communication with the external world in ways that was unimaginable before. That is the dream.